Hey there, Seahawks. It's Miss Adams, and in this video, we're going to explore biased and unbiased estimators. All right, so an unbiased estimator, if your statistic is not an underestimate or overestimate of the population parameter, then the statistic is said to be unbiased. If your statistic accurately estimates the parameter, it is said to be unbiased. So if your statistic is pretty close or exactly equal to your population parameter, then it's an unbiased estimator. It's a biased estimator if an underestimate or overestimate does happen in your statistic is biased. And then this little diagram, we have low variability. So variability is variation, which is how spread out things are. So low variability means it's all kind of close together. And low bias because it's close to the true value. So it says true value on the bottom where that is. And then if I move over the next one, it's low variability. It's not that spread out. It's kind of tight, but it's not very close to the truth. It's far off from the truth, so it's high bias. The next one, I have high variability, okay, because it's very spread out, but low bias because the majority of the points are closer to the truth. And then the last one, it's spread out, so I have high variability, and I have high bias because the majority of the points are not near the true value. So you want to have the low variability and low bias is what the goal is. Okay, this is what we're looking for. All right, important vocabulary and notation. So parameter are measurements of the population, a value that is obtained from the population. A statistic is a value that's obtained from the sample. Okay, so population, parameter, sample, statistic. If we're working with proportions, then P is our population proportion, and P hat is our sample proportion. If we're working with means, then mu is our population mean, and X bar is our sample mean. If we're talking about sample size, we use capital N for the population size, and lowercase n for the sample size. Okay? This problem, in a small town, John took a random sample of 5 households and calculated their median income. He repeated this process 40 times with replacement and displayed his results in the dot plot below. If the population median income is known to be $64,200, is the sample median an unbiased estimator? Okay, so we have this sampling distribution because each dot here represents the median income from a sample of 5 households. Okay, so the median income from a sample of 5 households is what each dot represents. Okay, and so we took 5 households, we found the median income, we plotted that median on the dot plot. Then I took another sample of 5 households, calculated the median, put that median as a dot on my dot plot. Okay. And then they told me that the true value, the population parameter, was 64,200. So I went to where 64,200 is, and I kind of drew a line. Then I said, okay, well, I have 20 dots that are to the left of that, and 20 dots that are to the right of that. So that would have been right about where I would have estimated my sample statistic to be. That would have been where I estimated it. So this is an unbiased estimator. Okay. If it's relatively even around the truth. All right. This other dot is saying the median income from a sample of 5 households is $55,000. The one I pointed to before was the median income from a sample size of 5 households is $82,000. Right. In a different town, John did the same sampling technique, but this time he calculated the average, which is the mean household income, and got the distribution shown below. If the census revealed the true mean household income is $55,350, is the sample mean an unbiased estimator? Okay, so we have this sampling distribution where it was a sampling distribution. He went to 5 households. He found the average this time instead of the median, the average household income, got the average, put that as a dot on my number line. Then went to another sample of 5 households, calculated their average, household income, put that as a dot on my number line. Okay, the true value from a census was $55,350 as the mean. Okay, is this unbiased? Well, it looks pretty biased since I have a lot more values on the right side of my line than I do on the left side. So this is a biased estimator. All right, go Seahawks.